Dear ladies and gentlemen, hello and a very good morning to all of you. This is Ahmed Zakaria here. Today I am here to present my research project. And the topic of my research project is effects of shredded tire chips and fine rubber crumbs on the stabilization of peat soil. So to begin with, these are the table of contents which I will cover in this presentation. I will talk about how tire waste accumulation has an impact on our cells and on our environment, what are the possible solutions, how we can control to it, and how scrap tire can be used in soil stabilization. Then comes the second component of my presentation, and research, it is the soil stabilization and ground improvements, in which I will discuss that what are my research motivation for studying the effects of tire waste products on the behavior of soil components. We will conclude it with the references. Now let's begin with what was the problem. The problem is the waste tires. The waste tire, we produce annually 1.5 billion of waste tires, which are, and majority of them ends up in the landfills. So where did it go? They go in the landfills, and here is the largest waste tire landfill picture, which is situated in the Kuwait. Now why is it happening? It's because of increased transportation and because of urbanization globally. This is a picture which is taken from the space of the Kuwait landfills, and the study shows that it already has 17 billion of waste tires buried in the landfill. Now moving forward, the impact of scrap tire accumulation. When they end up in the landfill, toxins, leachings and the materials go under the groundwater table, which disturb our ecosystem. Then if it burns down, it creates the pollution and which is health hazardous as well. Now what are the alternative solutions? It is to recycle of scrap tire. It's not being done on a massive scale because tire is made up of several products. So now it can be used. It can become a useful byproduct. It can be used in the construction industry, or it can be used to make a tire drive fuel. Now moving forward, what are the applications of tire waste in a civil technology? It can be used to improve the embankment for the railway, for the road and highways. It can be used as light fill material in the railway tracks to reducing of the vibrations, and also it can be used in the ground improvement. So now usage of waste scrap tire. It can form a bank alongside the river, as is shown in the picture, which is being already used, and when it processed mechanically or chemically, they are being used as the rubberized powder, fine rubber crumbs and the tire shreds, which will be using to stabilize the soil and enhance the soil properties. So what is the soil stabilization? Soil stabilization is an alteration of the soil to enhance its properties, and which eventually have the foundation, which is the foundation in construction, and geotechnical properties and physical and chemical stabilization in helping. So now why tire waste to be used for soil stabilization? Because it is cost effective, and it also answers the most concerned question, that is the solid waste management. So now the soil stabilization is means of improving strength parameters and characteristics. Its unconfined compressive strength is an important material strength of the soil. It is the compressive stress that a right cylindrical sample of material can withstand in unconfined conditions. Now the second thing is the California bearing test, which is the penetration test to evaluate the strength of the subgrade for the roads and the pavements. Now the soil stress capacity. Soil stress capacity is the maximum average contact pressure between the foundation and the soil. So now, and moving forward, it's the permeability. The soil permeability is the property of soil to transmit water and air into the soil to make it to reaches to the groundwater table. The picture shows the impermeable layer and the permeable layer, how it affects our groundwater table. So now what are the relevant researches on the soil stabilization? The literature shows that sand, slag, lime, fly ash and scrap tires when mixed together can be used and in the weak soil, which can withstand the stress and load. Many studies have suggested that reinforcing these type of admixtures can also improve textures and properties. Now how it is cost effective? Ramaji has recently in 2012 presented in his reviewed article that the waste tire shred and crumb is not only the most cost effective but also a good stabilizing agent as well. When mixed with cement, lime and scrap tire, they the good stabilizing agent for the weak soil. And now the efficient method for weak soil stabilization and size of rubber crumb chip was suggested to have an influence on the soil properties. Now the ground improvement using tire waste. The tire shreds, chips, rubber crumbs improve UCS and CBR value. It needs through accurate value testing. And now the interaction of clay with rubber fiber crumbs, shredded geotechnical properties. Now the percentage of 7% to 10% addition of scrap tires in the present admixtures can affect the UCS and the CBR values. How an addition resulted in downward trend. Now and furthermore, the scrap tire has also shown to improve the ductility, permeability, internal angle friction of the soil. Then the curing period has also shown improvement in strength of parameters of the soil. And the other study done by Yadav and Tiwari, the reinforced cement and stabilized clay soil with shredded rubber further improve the soil properties. Therefore, binding agents such as lime and additives can also improve the ground improvements. Now, why I am deviated towards the stabilization of weak soil? Peat, for the peat weak soil. The peat is classified as a highly organic soil when matter or it is formed when organic matter accumulated more quickly than it decays. The properties of the peat soil are lower shear strength, high water content, and low compressibility. So Saberian and Raghuser and Wongs, they have researched on the stabilization of peat soil and peat soil behavior to make it possible for construction. So now my research motivation and identified gaps were there were not many of the research presented for the stabilization of the peat soil, whereas mostly studies have been done on the clay properties and characteristics. Although Saberian and Raghuser has done their research on the peat soil stabilization, but again it was limited to the Iran. They conducted their survey on the Iran, so it cannot be generalized because of geographical location. So therefore, stabilization of peat soil is an area which hasn't been discovered. So my research question, the first one is how will the peat samples from Australian wetlands be influenced by rainfalls of shredded tire chips and rubber crumbs on the measures of permeability, internal angle of friction, cohesion coefficient, unconfined compressive strength, and the California bearing ratio. The second question is what will be the effect of curing period, and addition of binders such as sand, lime on the test samples. Now this is the research design methodology. Experiment design will be used. Procurement of peat samples from wetlands, and yeah, the shredded chips and tires will be introduced by 5%, 10%, 15 to 20%, gradual increasing. And the curing period is very important, which will be observed with 7, 14 and 28% data for the samples. Its unconfined compressive strength, California bearing ratio, permeability, internal angle of friction, and cohesion coefficient will be calculated. So these are the references which I have used in my presentations. Thank you very much, ladies and gentlemen, for listening to this presentation. Take care. Bye.